Hello friends, welcome to the BSC IT Semester 5 Internet of Things video practical demonstrations. Today's practical is displaying different LED patterns with Raspberry Pi. So this is the program that you're going to write in Python IDE provided by Raspberry Pi microcontroller. First of all, we'll try to understand what this program is and how this program is written. The first statement is import rpi.gpio as GPIO. This is the package that every program needs to import. As GPIO is the object name, this GPIO is the object name. You can use any other name to make this object. Make sure whatever name you're going to use here, the same name will go to all this, because this is the object used everywhere that we have created here. Next is import time, because we are going to create the LED pattern using delay function. So this delay can be used or this delay can be implemented with the time package. So the function that we are going to use for a delay is sleep from this time. Then the next is GPIO.set mode. Now here the GPIO mode set is BCM. This is called Broadcom pinout. If you don't want to use the Broadcom pinout, you can use here GPIO.board. So it will be according to the board pin numbers. So the pin number which are displayed on the board or which are used as the generic board, you can use those pin numbers accordingly. I am using here the BCM Broadcom specifications of that pinout. The next is you can write this statement to set off the warnings, otherwise these warnings will keep coming while the program is executing. So it is always good to write this statement. Then the next is we are setting up some pins, that is 18 number pin on Broadcom pinout 23rd, 24th and 25th as output. So this GPIO.setup 18, GPIO.out means these are the pins which we have set as an output. Then since it is going to glow these LEDs in some pattern forever until there is an external stop action, so we need to keep it into a while loop. So while 1 will be an infinite loop, and after that we are using this delay of 2 microseconds. So 0.2 is actually it's not microseconds, it's milliseconds. So this way we are using the delay using the sleep function. When at first we are setting the output of 18th number pin to be high, 23rd pin to be high, similarly for 24th and 25th. After some time of delay, then we are setting these pins to low. This is the first pattern. Again, this pattern will be followed by another pattern that pin number 18 will remain high, where 23 will go low, 24 will remain high and 25th will go low. Then to create another pattern, 18th number pin will go on low, and according 23 is high, 24th is low and 25th is high, and this will be in a loop, in a continuous loop, and it will create a pattern of LED glowing. This is the Python IDE that we are going to use to write a program. I will be demonstrating that too, that how to create a program and how to write a program and how to execute the program. This is the setup. Here you can see that I have used 4 LEDs as we have used 4 pins as an output. This is the Broadcom pinout specifications that I have used using T connector. I'm not using I'm not actually dealing with the Raspberry Pi pins directly, but I've extended those pins using this T connector on my breadboard. So all my dealing with will be with this T connector. Then this pin number 18, pin number 23, pin number 24 and pin number 25 are extended here through the registers. We have connected it to the LEDs. There is a ground pin which will be connected to this to make the connection or to make the circuit complete. Once the circuit is complete, and the program is executing, these LEDs will be glowing in some pattern. So here I will be demonstrating that how these LEDs can be programmed to glow in some pattern. Let us set up the circuit for displaying different LED patterns using Raspberry Pi microcontroller. So this is the Raspberry Pi microcontroller with 40 GPIO pins, USB sockets, Ethernet connection, 3.5 audio jack, display, HDMI display. This is the power supply, USB power supply. I am going to use Wi-Fi to connect this Raspberry Pi with my laptop. So the operating system display of this microcontroller is going to be extended through VNC viewer in my laptop screen. I will be demonstrating that also. So first of all, to set up the circuit for different LED patterns, we need a Raspberry Pi. I'm going to use 4 LEDs for different patterns. So I have taken these LEDs. I also need some resistance before the LEDs. So I have taken the resistors. Then I have taken this male to male jumper wires because I'm going to use the breadboard with this T connector. If you don't have this T connector, you can simply use a breadboard, but in that case the jumper wires that you're going to use will be different because you cannot connect these jumper wires from breadboard to the pins in this way. So for such you need such type of jumper wires which are female to male connectors. So in this way you can insert this female end in this pins, and then you can extend the functionality of these pins here in the breadboard. I generally don't use such female to male jumper wires because here you need to come across these pins directly with your bare body, and that's why I'm not using these jumper wires, female to male jumper wires, but I am using this T connector. I have got these 40 slots which I can insert into these 40 pins in this way, and the whole functionality of this Raspberry Pi will be here on this breadboard using this T connector. Furthermore, I don't even need to remember the pin and their specifications. The whole pinout according to BCM pinout I have already extended here onto this T connector. So now let us put the LEDs onto this breadboard. So LED have 2 legs. The leg which is a longer leg with small filament is the positive side of the LED, and the LED with shorter leg with the longer filament is the negative side of the LED. You can call them as cathode and anode. Then you can see here that this first pin is plus 3 volt, second pin is 5.0 volt. Even this fourth pin is also 5.0 volt. Similarly, some pins are there marked as ground. Some pins are marked with hash tag like hash 18, hash 24, hash 23, 25, etc. These are the GPIO pins that I am going to use to connect the LED's positive side. So according to the program, we have used pin number 18. So I'll put this jumper wires next to the pin number 18. So in this vertical line, you can put this jumper wire pin one end to any of this hole. So this is 18 number pin. According to the program, we have used pin number 18, pin number 23, pin number 24, and pin number 25. So you see, these are pin number 18, pin number 23, 24 and 25, and next to them I have inserted these jumper wires one end. Now this second end of these jumper wires, you can place them according to the order. So red colored wire is the first one, so I'm putting it somewhere here. Then next is the green, so I'll just take or use the gap so that it will look a sorted diagram. Then next to this, you can use a register. So you can place the register, because next to this registers I'm going to place the LEDs. So if you are not going to use the registers, that is still okay. So this way I have placed all the registers. Now, as I said, the longer leg is the positive side. You can also check the smaller filament is the positive side. So this positive side is to be connected to the register side, and then you can place these LEDs like this, or else you can place these LEDs in this way, and you can extend the register leg to the positive side of the LED this way. Now all these LEDs are connected with the positive voltage. These are the GPIO pins. Through programming, we are going to set these on and off, and the same logic will flow from these jumper wires and to these registers to these LEDs. So whenever we want to put them on or off, they will be glowing accordingly. Now all of these LEDs need to be connected to the ground. So this is the ground pin according to the BCM pin out. So I'll put this jumper wire, and then we'll provide this ground connection to this line. So remember, for a breadboard, this whole horizontal line will get the negative connectivity. So in this way, we have completed our circuit. Now let us see how it works in terms of the output. These LEDs will glow in some pattern according to the program that we have written. So if I'm going to power up this Raspberry Pi with this USB power supply, I need to connect this to this end to the 230 volt and this USB connector to the Raspberry Pi. If I'm going to power up this Raspberry Pi will start loading the operating system into it. Since these are the positive voltage pins, they will also pass on the positive voltage to these LEDs, and these LEDs will glow. So here we go for powering up this. Here I am going to tell you how to connect your Raspberry Pi microcontroller to your laptop or desktop computer screen. To do that, you should first know the IP address of your Raspberry Pi microcontroller. Remember, your Raspberry Pi microcontroller needs to be connected to the same Wi-Fi with which your laptop or a desktop computer is connected. So to start with, type here advanced IP scanner. This advanced IP scanner will provide you this ID where you can click on this scan button to scan the different devices on your LAN network. So this will scan all the devices which are there on the same LAN network. So it will take a while to search the different devices on your network. So you see, you got this Raspberry Pi connected on this network. The IP address of this Raspberry Pi is 192.168.43.165. To access this, you need VNC viewer. So type VNC and you will get this application. So click and open. Now you have to click on file, click on new connection, click here the IP address of your microcontroller which you have just searched. So it was 192.168.43. Let me just check. 192.168.43.165. So here it is the IP address. The identifier name can be any type. Right now I'm writing ARDI. Click OK. So this will be created. So now if you want to access this Raspberry Pi microcontroller with the given IP address, we have just made a new connection. You have to just double click on it. You need to give the username. So for username, by default username for all Raspberry Pis is Pi, and the password is the Raspberry small letters, all small letters. You can also change the password. So this is how the screen of Raspberry Pi can be extended on the laptop screen. So to create a new program, new Python program, here is the way. So click on this programming, click on this Python 3 IDE. This will give you this command prompt where you can actually execute your program if you have already written. If you want to create a new Python program by entering the code, you can click on new file. So this text editor you will get where you can actually write. This is interpreted text editor, so you can use this interpreted text editor. Otherwise you can open the program that you have already written. So I have already written the program which I had just explained in my first section of this video. So just browse through the directory. This is the directory home/pi where all your Pi scripts will be stored. From that you can browse through that program and open it. So this is the program that I have just explained. So you can see this. In Python programming, this indentation is very significant. So you should be aware that where your for loop starts and where it is ending, there is no need to show the end with curly brackets or any semicolon in Python. Then if you have made any changes, you can check this with check module. So if you get any error, that will be displayed here. If it is not, that means your program is all correct. So to execute the program, you can click on run module. So after clicking on run module, you see the output will also be displayed here, and the output will also be displayed on the circuit which is connected to the Raspberry Pi. If you want to stop this, you can press Ctrl C. So this is how this while loop, this infinite while loop will come out of the loop and your program will stop the execution. So this is what happens when you click on run module. Here you see the output will be displayed here, as well as the output is displayed, or the output is actually executing on the circuit that we have just set up. So through this Raspberry Pi, this output in terms of LEDs on and off will be shown on this circuit this way. LEDs are glowing in some pattern. So for a while we have kept the LEDs high. After some time they will go to low, and we have created some pattern so that these LEDs are glowing in some pattern, going off and going on in some pattern. So this is how you can use the you can even you can use multiple LEDs, even more than 4. You can have 8 LEDs over here, and you can create a pattern accordingly. So for them you can use any of these GPIO pins. There are a few more pins like hashtag 12. This pin number you can use 16 hashtags. This is all about BCM specifications, so you can use this pin, this all 16, 20, 21. In board, in Raspberry Pi board mode, these pins will be count in terms of 1 2 3 4 5 6 7 8 this way. So this will be the 40th pin, so this will be the 38th pin, this will be the 36th pin, and so on. So that way you can use these different utility pins to use multiple LEDs here and to glow them in some pattern. Thank you for watching this video.